If you're trying to tell if something is a function, you have to kind of remember this definition, and this definition is in my own words, but for every input or x value, there has to be exactly one output or y value. So if we look over here, if we're given a mapping, it doesn't label which ones are the x's and which ones are the y's, so you would want to go ahead and label those first. And then you would want to look at each of your x's. -7 goes to exactly one y value, so that's good. That's okay. But here we have 11, and when we put in an 11, we could get either a 5 or an 8. Since 11 goes to two different y values, that makes it not a function. So we can eliminate anything that says yes. No, because the x value 11 has two y values paired with it, or no, because the x value has only one y value. If the x value only had one y value, that would be a function. So this one is our answer. And let's look at another example of that. All right, which ordered pair, oh, nobody has the answer, but that's okay. Which ordered pair could you add to the following list of points to create a function? So we already have the list, and I'm going to just move this 3, 5 down here so I don't forget it. Each of our x values has to go to exactly one y value. So 4 has to always go to 9. 2 has to always go to 5. 3 has to always go to 5. It's okay that more than one thing has the same y value as long as each x value only has one y value. So if we tried to add the point 3, 7, that's an issue because we already said that the x value of 3 gives us 5. It can't give us 5 and 7. If we try 4, 1, we already said that 4 goes to 9. So 4 can't go to 9 and 1. That makes it not a function. If we looked at this one, 2, 6, we already said that 2 has to go to 5, so that's not okay. Here, if we look at 1, we haven't even talked about 1 as an x value yet. So it's totally okay if 1 goes to 9. That would still make it a function. And remember your definition. For every input, there has to be exactly one output. Another way they say input besides x value, sometimes they'll call this the domain, and sometimes they'll call this the range. But that is how you tell if something is a function. You can also look at graphs and t-tables, but that same definition has to be true for all of them. All right, a plumber charges a service fee of $40 plus $25 per hour for labor. Write a function rule for the total cost of hiring the plumber for a job that takes X hours. So we know that it's $40. We know there needs to be a plus sign, and then $25 per hour. And it says over here to let X represent hours. So $25 per hour means that we would multiply by X. So that's how we would write the function rule. And the order when you're adding doesn't matter. So this could be written as 25x plus 40 or 40 plus 25x. When you add things, you can add in any order. So let's just make sure that the 25 is with the x. Here it says $40 per hour, and that's not what the problem says. So those can cross out. All right, so both of these functions are correct. Part B says, how much would it cost to hire the plumber if the job takes 4 hours? So we are going to take our 4 and plug it in where we see x. So I'm going to come up here and I'm going to do 40 plus 25 times 4. And I'm going to do the same thing here, 40 plus 25 times 4, and I'm going to see which one gives me the right answer. 25 times 4 is 100, plus 40 would be $140. So it does not equal 185, it equals 140. So 185 is incorrect, meaning that this would be our correct answer. All right, write the function rule. And there's a hint over here, y equals mx plus b. This is our equation of a line. This is also our function rule. Remember, the m is the slope or the rate of change. That's the definition of slope, rate of change. And the b is the y-intercept, or where it starts at, where it crosses the y-axis. So if we're going to think about our y-intercept first, if we think about our y-axis, in order for it to cross the y-axis, in order for it to touch here, the x value has to be 0. If the x value was positive, you'd be over here. If the x value was negative, you'd be over here. The only time that it touches the y-axis is when the x value is 0. So we want to look at our t-table, and first we want to say, okay, when x is 0, what does y equal? So we have a point at 0, 10. That is our y-intercept because that touches the y-axis. So we know that our b value for our equation has to be a positive 10. So I can go ahead and mark out that negative 10. That's not going to be right. And I can mark out this negative 10. That's not going to be right. And then to find your slope, you can go ahead and label your x1 and x2 and your y1, and y2, and then plug them into your slope formula. y2 minus y1 over x2 minus x1. So this would be 8 minus 10 over 1 minus 0. 8 minus 10 is negative 2 over 1, which equals a negative 2. So that means our slope has to be negative 2 times x. This is a positive 2, so I know that's not my answer. So it has to be this one. Y equals negative 2x plus 10. I'm going to go ahead and get rid of this because this got really messy. All right, let's look at the next question. It says, which linear equation represents the graph? So I know this graph is really hard to see, but when we're trying to figure this out, we need to figure out our slope and our y-intercept. I like to find the y-intercept first. So I'm going to look at my y-axis and I'm going to follow it down until it touches. Wherever the line touches, that is my y-intercept, which looks like it's at negative 2. This says positive 2, so I know that's not the answer. This says positive 2, I know that's not the answer. So I've already got it down to a 50-50 guess. From here, I need to look at my slope. Without even doing the slope here, remember, if you take a ball and you imagine putting it on the left side of your graph and asking yourself what's going to happen, this ball will roll downhill. So I know this slope is negative. So before I even do my rise over run, I know it can't be positive because it's not going uphill. But if you wanted to double check it, you could pick 2 points on the graph and you could say, okay, I go down 1, 2, 3 over 1. So your slope is negative 3 over 1, which equals negative 3. This one says determine whether the sequence is arithmetic, geometric, or neither. Remember, arithmetic is a sequence that adds or subtracts. And geometric is a sequence that multiplies or divides. So we're really just trying to figure out if we add or subtract the same number every time, or if we multiply or divide by the same number each time. So what we're going to do, we're going to check to see if it has a common difference, which is the letter D. We're going to check that first. And if that doesn't work, then we're going to check to see if it has a common ratio. So for the common difference, we always start at the back. We're going to do 8 minus 40, which would be a negative 32. And then we're going to do 40 minus 200. You start at the back and you work your way forward. That's not going to equal negative 32. That's going to equal negative 160. So this does not have a common difference. So it is not arithmetic, since those are not the same. Now, if we wanted to try geometric, we do need to test it because it might be neither. So we start at the back of our list, and for geometric, we do ratios. So I'm going to do 8 over 40, because that's a ratio, and that is 1/5. And then I'm going to do 40 over 200. That also equals 1/5. You do have a common ratio. You are dividing by 5 each time. 200 divided by 5 is 40. 40 divided by 5 is 8. So this is geometric because it has a common ratio. If you did not know how to reduce these fractions, that is totally okay. Remember, you can always use Desmos, and you don't even have to leave them as a fraction. You can turn them into a decimal. But you could do 8 divided by 40, and then you could do 200 divided by 40, and you could, wait, was it not 200? 40 divided by 200, geez, did that backwards. 40 divided by 200. You can see that they have the same answer, so we do know that they have a common ratio. All right, so that is geometric. Let's look at the next one. What is the slope of the line x equals -3? Now, usually we're looking at our equations in y equals mx plus b form, and the slope is the number attached to x, but this is not in that form. If you graph this line, it says that the x value always has to be -3. No matter what, the x value has to be -3. So if the y value is +1, x is still -3. If the y value is 10, x is still -3. And if the y value is -20, x is still -3. X has to equal -3. So this gives us a vertical line. And in a vertical line, the slope is undefined. Because if you did your rise, let's say that you rise 1, you're going to run over 0. If you rise 3, you're still going to run over 0. Anytime you have 0 under the fraction, that is undefined. All right, what is the rate of change for the following equation? Rate of change is the definition of slope. So that tells you you're looking for slope, and we know the slope is the number attached to x. So my rate of change has to be 8. We have to rise 8 and run 1. At what rate did the rain fall? Again, it's talking about rate, so we need to figure out the slope. So I'm going to look over here at my graph. I'm going to start at 0, 0, and then I'm just going to put some points that cross the grid. You can use any of these points that you want to. So if I want to know the rate, all of these rates are per hour. That's a unit rate. Remember we talked about that last semester? So I really want to look down here at 1 hour, and I want to see what's happened at 1 hour. And if I go up, I can see that 2 inches of rain, or 2 centimeters of rain, fell within 1 hour. So the rate here is 2 centimeters per hour. Now you might get confused if you try to rise up 2 and over 1, but even if you do that, that would still be 2 over 1. So no matter what, I think you can see that the rate is 2 centimeters per hour. Which of the following represents the linear relationship with the greatest rate of change? So we're looking for the biggest slope, because remember, rate of change is slope. Here, my slope is 2 because it's the number attached to x. Over here, it says a line rises 9 units for every 3 units it moves to the right. And 9 over 3, because we do rise over run, equals 3. On the graph, we would have to pick out 2 points and count how many you rise up. 1, 2, 3, 4 over 1. Well, that equals 4. And then on the table, we could find, we could do the slope formula, or we could find the rate of change, how much it's changing each time. Over here, we're adding 1 each time. And then over here, we're adding 5 each time, I think. Yeah, 5 each time. So this slope would be 5 over 1, which is 5. So the one that has the greatest rate has to have the highest slope, which is B. So this one says, describe the bus's motion from point B to point C. I'm going to describe the bus the whole time. On the x-axis, we have the time, and on the y-axis, we have the speed. So from 0 to 5 hours, your speed is increasing. It's going uphill. From 5 seconds to 12 seconds, or sorry, that's 10 seconds, we haven't stopped. We have kept our speed the same. Our speed is at 10 the whole time. So this is going to be where we keep our speed the same. And then from B to C, this is what it's actually asking for. This is when we're slowing down. Slowing down. Down here, we actually are stopped because our speed is 0. So this is where we're stopped. This is where we're increasing, and this is where we stay constant. It means your speed doesn't change. Constant. You're not increasing or decreasing, you're just keeping your speed the same. All right, which line is the steepest? The one that's going to be the steepest is the one that's going to be closest to vertical. It does not matter if your slope is positive or negative. You could also compare that to this and still say that this one is steeper because it's closer to vertical. So don't worry about positive or negatives. If it's asking for the steepest, it's just which one is closest to vertical. If they're comparing, like on this back here, if they were comparing, equations, tables, graphs, all of this, and it says which is the steepest, whichever one has the biggest slope is the steepest. All right. For this one, it says, which is the graph of the line y equals negative 2x plus 2? If our y-intercept is plus 2, it has to cross the y-axis at positive 2. That one crosses at negative 2. This one crosses at positive 2. And this one crosses at negative 2. So I know that B and D are gone because it does not cross the y-axis at positive 2. And then I'm going to look at my slope. Remember, the slope is the number attached to x. I don't actually see a number here, so I need to put a 1. My slope is negative 1. Because it's negative, I know that when I put a ball on the left side of the graph, it has to roll downhill. If I put a ball on the left side over here, it would roll uphill, which would mean this was a positive slope. So I know it's not that. But if you wanted to double check that, with the slope, you could do rise over run. You could go down 1, over 1, and you would see that that is going to give you your line no matter how many times you do it. So your answer is A. Last one. It says, what are the next 3 terms in the sequence? So first we have to figure out the pattern of the sequence, and then we can find the next 3 terms. So we're trying to ask ourselves, how did we get from one number to the next? If you can't automatically tell, remember you can find the common difference, which means start at the back and subtract the number in front. And you can do that a couple times just to make sure it always works. Remember, 2 negatives make a positive. And so it does work. We are adding 3 each time. So if we want to find the next 3 terms, we need to start with this term and add 3 to it. 3 plus 3 is 6. Then we need to take 6 and add 3. That would be 9. Then we need to take 9 and add 3, and that would be 12. So your next 3 terms would be 6, 9, and 12, because you need to keep adding 3 each time. All right, I hope this video helps, and good luck on your Unit 3 test.